Welcome to Open Source Spotlight. We invite open source authors and ask them to show the tools they're working on. Today we have Florian. Hi, Florian. Tell us a few words about yourself and about the tool you want to show us.
Hey, Alexey. Thanks for inviting me. So, Florian from Berlin. I work in this startup called Jina AI. I think we get now more popular over time. And what we're starting with is building up neural search framework over the last 5 years. We started completely open source. And then we now found our niche in this search vertical. So we create all kind of tools that are used to create a search engine. So starting with data processing, reader, something we will also talk soon now, because it's part of this project I will present today. And also creating embedding models and re-ranker models, and even end-to-end applications in search.
And especially now with the popularity of RAG, Jina becomes more and more interesting, right? Because this is one of the components you need search in order to do RAG.
I think so. So at some point we thought, actually, who needs these search frameworks? And you have LLMs, and they can do much better in answering all these questions. Who needs search engines? And then these RAG applications come up, and this is actually still gave us a lot of relevance and much more than what we thought with this disruption.
Mm-hmm. Yeah, cool. So you want to show a demo?
Yeah, let me quickly find. I need to share my screen. Okay, so what do we have here? So this is our node-DeepResearch project. So what that is you probably heard a lot about all the reasoning models, and then many companies publish their own version of agentic problem solving, but now also agentic search. I think Google was developing such thing, then also OpenAI, and then this is like our version. And it's not that all these companies copied each other. It had to bring something out. It's more like the logical next step. When you have reasoning and you have search engines, it just makes sense for the AI agents to use the search engines to provide better results. And what we have here is our open source solution. Of course, like certain things you have to provide, like for instance, Gemini API key or OpenAI. So because this code has to use some language model, some reasoning to then come up with the search queries and then also provide the final results. And what is also possible to input a Jina API key. This is not just calling our servers to do the actual work. This is just integration with Reader, and it's also Reader is also open source, right? So you could also set up everything locally, theory. So then you can provide Jina API key, which is also free for 1 million tokens, so for almost everything you do with this. But you can also set this up locally. If you want, I can give a demo.
Yeah, and maybe before we start with the demo, just a quick question: what exactly is a agentic search? What is that?
Yeah, okay. I should
Maybe we'll
this
see this in the demo. I don't know.
Yeah. So search is just user provides a keyword or some question, and then the search engine retrieves the answer.
This is what happens when I go to Google, right? So
go
to Google, write Jina AI, and then I see some results. So this is the usual search.
Yeah, this is what we are all used to. And then these RAG applications came up you talked about, where it's one step in between, where not the actual user search query is taken, but the language model comes up with some better, more understandable query, puts this into a database, and then retrieves documents, and then combines all this knowledge from all these answers, and then provides a final response to the user. But this is just this single step. Sometimes also the user query is taken directly to the search engine, or something language models in between, but it's usually just this one step, one iteration of taking user input, finding documents, providing an answer. And this agentic search is taking this to the next level, where it doesn't give directly the answer, but can do another search request and another one and another one, and explore the whole database or the whole search engine to then provide a final answer that is much more in depth.
It's interesting. Okay.
Cool. Then yeah, let's see. So we can. So you have to first install this, and then provide this variables, and then you can just do npm run dev, and then provide a query. And do you have something in mind we should try out? Something that DataTalksClub?
Okay, DataTalksClub. But like, should it be a question or?
It should be some question, something we want to find out.
So I am preparing now to run for the Berlin Marathon. So let's ask it, how do I prepare?
Okay. How do I do it for
Maybe just for a marathon, not necessarily the Berlin one, but could
I
be.
mean, we can maybe for Berlin, you have to prepare something very special.
Go to Bergheim.
So this this new paradigm of search is also something where we put our requirements to search engine much higher. So we are used to be very kind to the search engine, to not make it too complicated for it. But now that it can, it has actually an agent that interacts with its search engine, our question can be much more precise or much more in depth. Okay, what we see here is a lot of clever looking terminal output. What it was actually doing is going through multiple steps of asking questions and checking out a lot of content online, so even YouTube videos. And these are all the references it visited URLs. And at the end, after a lot of reasoning, it gave this final answer. So, okay, what do we have? So training.
Okay.
16 to 20. Do you still have so long time?
It's in September, so I guess.
Okay, it could work.
Okay, and what exactly did it do? So I saw a few things. So I first saw that it expanded the query into multiple queries. And then also what I saw budget. So what do these things mean? Like, first of all, how does it expand the queries? And then what exactly the budget is? And then like what exactly it was doing in order to come up with this answer?
So maybe we find this so something like this, right? Where it's generating multiple queries. So that's called query decomposition. So sometimes queries are very long and contain so many different subjects. And then, as you also said, okay, how likely is it that I get information to prepare for a Berlin Marathon? When you type this into a search engine, there's maybe only one website covers this. and then you don't find enough information. So then this agent is taking exactly this task to decompose the query. So it also generates some queries that are not Berlin specific.
Yeah.
But go about specific aspects.
Yeah, it's
And try
interesting
to find
because
this.
like it talks about not just training plan, which was my original query question, but also it talks about nutrition, strength training, injuries, running shoes, so and then even course tips, right? So like it understood that these things are also important if you need to prepare.
Yeah, it was not, so maybe you had a training plan in your head, but we searched about how to prepare for a marathon, and then these are all parts of the preparation.
Because if I was to Google this to look it up somewhere, I would just focus on the training plan, but this agent was smart enough to take other aspects into account. That's cool.
Yeah, it can also happen that it comes up with things like we really don't want to focus on. So maybe it's not relevant to us, the like injuries or so, because we think, okay, that's makes sense to us, but I don't want to make it search for this. And this comes from every query we write is heavily underspecified, especially in the way we used to search on Google. You can, with like a 3 keyword search query, you cannot really pinpoint the intent the user has. And I think the next step here would also be to ask the user some question to clarify. So it could be a short dialogue before to ask you, okay, is this really, do you want to focus on injuries, or is it really specific to Berlin, or maybe also focus on other cities and so on? Or you only want to have these tips for Berlin and not general tips at all? And then what level did you run a marathon before? It could first have this conversation and then go and search for the in-depth what you're really interested in. So this is possible improvement actually.
And the budget, what was that about?
Yeah, good points. So we learned relatively quickly that so the more questions are answered, of course, the more new questions come up. We experience that in our daily life. So the same issue with the agent. So it finds more websites, and then it discovers a totally new field at some point. Maybe something it didn't think before. So this list of queries extends over time because it discovers a new aspect of what preparation also could mean. And then it will just never stop. So we put a budget threshold. So you can define how long should, or how many tokens should this agent process until it finally says, come on, that's good enough. I should just give an answer.
I see. So it's like when we work on a project, we can spend a day working on the project, a week, a month, right? And we say, okay, let's just do whatever we can in one day, and that will be it. And the same here. Like you can let it explore for a long time, but it will already give a very good answer if you just let it explore for, I don't know, 30 seconds or whatever. But
in your a trade-off, basically,
the budget is what is it? Tokens? Is it time? What is it exactly? Or export URLs?
So it's tokens. It's like almost equivalent then to euros. So as like you would think of a budget.
You also have a web interface, right? So it's not the just command line tool.
So this is just this command line tool, but we also have a web interface. That's true. That's search.jina.ai, and that's using that in the background. But I mean the search, or the front end is very very lean. Just a white page with a box, and you can enter, and then you see streaming output from here.
So what is also interesting here that we didn't talk about in this output?
Yes. What we didn't talk about is actually the think. Just talked about making a lot of search queries and so on, but how did it even come up with that search queries? What we see currently, previously AI models, there were a lot of compute put into training AI models to make them perform good. But then the AI research field saw there's some kind of limitation of how good AI models can become when you just continue training them. And there's a new paradigm emerging that is called inference time or test time compute, where people see when you let the language model just generate for a longer time, then also the results become better. So then it's they get a boost from better training, but also from just letting them think for a longer time before they come up with a result. This came originally from chain of thought, but then it's now going to like thinking for 10 minutes or something like this. And that's what we also see here. So there's not only the action it's called that is a search action, but actually what also happens is it has some think action where where it thinks about what is actually going on, what do I actually need to do, and what search queries could be relevant in that specific scenario. And you can look at it and see how it thinks about this and therefore improves the quality.
Yeah, that's amazing. Is there anything else in the output?
Yeah, so when we will reach the budget cap, so what will happen? It will not just through an error and say, "Oh no, I failed, generate a new one." But when this budget cap is reaching 100%, then it will interrupt all the thought process, everything, and really force the LLM to take a decision, generate a final answer, given this knowledge. Before, it's always giving the LLM the opportunity to either provide the final answer or go into another thought stage or another search stage and so on. But here, when it's reached 100%, we really say, no, this LLM, please, given all what happened before, generate the final output. Yeah.
Interesting. And all the prompts are also open source, right? We can see them.
Yeah.
Yeah, and if we wanted to do this, where can we find them?
So for instance, here.
This is queryrewriters.ts.
Yeah. So this is for the first question you asked, where it's about the initial user query, how it's decomposed into subqueries. And then you can see this is a very long prompt actually with a lot of few short examples. So, and then it says, yeah, you're this expert in query generation and so on. And then yeah, it goes to some instruction and good tips on query decomposition, but most importantly, I think, is the examples we have here. So it says, for this input query, generate a thought step and then output some queries. And we have this in multiple languages. So this is the English version. So input query is Python, Django, authentication best practices. And then it explains the thought progress. And then, yeah, it gives some examples of these are good queries then in that case.
Okay, interesting.
And yeah, given these few short examples in multiple languages, it can also then generate something like we have seen here before in the log output.
Okay,
Yeah.
amazing. And how many people are working on this?
So this was initially created by our CEO, Han Xiao, who is a well-known researcher in the community. Actually, the main initial driver or visionary behind all our projects. So he usually creates the frame of a project or the initial setup, and then other engineers jump in. So I think like then 3 or 4 more engineers from our side.
Is this open for contribution? Like if somebody externally wants to contribute, how do they go about that?
Yeah, this is always a bit difficult, how to contribute. So we're working in this company, so for now 5 years, we had like we have a huge open source community. Because one of our projects, this Jina project, has like I think 40,000 stars or something. And over the years, we had many contributors, but sometimes very difficult for people not working in this company then to make contributions in the core things like in the prompt and so on, because of course we have a lot of discussions internally, and then it might not align with pull requests. So over the year, there were very few pull requests that get actually then merged. So what I think, what over the years created the by far most valuable contributions is finding out cases where it doesn't work. So when people can show us, I tried this query and open ticket, hey, this doesn't work. This is and then maybe even also trying to fix it. Yeah, but it's not even necessary. Yeah, but if they show us where it doesn't work, it makes us move so fast because we get this immediate feedback, and it pushes us a lot, driving this project further.
Yeah. So speaking of stars, maybe you can show us how to give you a star.
Yeah, I've only shared this screen now of my development environment, but yeah, you can go to our GitHub page and then hit the star. But
So which
more
one should it be?
importantly, but most importantly is stars don't matter so much in AI world nowadays. So most importantly, try it out and
Okay.
yes, show us where it fails.
The project is node-DeepResearch, right?
Yeah, exactly.
Okay. And it's in your, we will of course include the link in the description. But also you have a bunch of other projects, including the one you mentioned with 40,000 stars, right? This is the main Jina project, right? The
Yeah,
neural.
it is where we came from, but it's also not so relevant nowadays anymore. So we have a reader. This is also another link we can include, because this is actually, it's based on top of this other open source project, which is called Reader, which is giving this a lot of power actually.
And what does the reader do?
The Reader, it can search online for websites, but also can parse the website into LLM readable format. So this agent then finds out nice links from websites that supports certain hypotheses or where some information is included. But then with Reader, it can also open that website and read that website content, and not with a lot of HTML and CSS and this weird formatting, but just nice markdown format, readable for LLMs.
So the way it works, you find first a bunch of search queries, and you use the search engine to find the web pages for these search queries. But then it's just URLs, right? So you need to extract the content from these URLs, and this is where the reader comes into picture.
Exactly. For the search from the search engine, we just get a snippet, small text containing the essence, but of that query answer. But it's a lot of cases, if you want to have a real investigation, then like a user, you would also not just look at the snippet in the search result, but you would also click on the website and then read all the information or all the relevant one.
Amazing. And maybe the last question I have for you is, do you have any advice to anyone who is watching this?
Okay, so if someone is watching this, they're probably interested in AI and want to just learn more in general, and probably think AI is future of everything. So I think it's a bit underestimated what you can learn from just, or overestimate what you can learn from just watching. But I think by watching such a video, it can give you some motivation to now actually try out this tool or other tools, or try to create a prompt yourself, try to replicate what I explained here, and build your own open source project. And by doing this, you learn the most, and much more than just watching. But watching such videos can also give you impulse, but then you need to start action.
Yeah, that's amazing, an amazing piece of advice. Thank you, Florian, for finding time to join us today to do the demo. And also thank you for making this tool open source. So it's really amazing. Thanks for making it possible for us to use such tools. Thanks.
Well, thank you. Bye-bye.